Okay, so first of all, the most important thing I want to tell you, and by the way, this is posted, as I said, on Blackboard. Look at the homework folder. The project, the 3 parts, 4 parts, I forget, 4 parts. Okay, so this is the first of all, the trajectory tracking, which I'm going to talk about today, is the last uh, part which has a homework assigned. So I already posted the homework, the 10th homework, then no more homeworks, because the next 4 weeks we're expected to work on the project. And with that said, let me just tell you a little bit more about the project. So you can read through this. Let's start with the more obvious part. So the project can be done individually in a group of 2. So you are free to choose anybody you want to in the project. Just keep it to 2 people. You don't have to choose the same person you're using for the homework. It could be somebody else. That's absolutely fine. If you've been working individually in the homework, you could work in a group. That's absolutely fine. Another important thing is that this is not a research project. I don't want you to spend like lots of time doing the project. It's just an assessment of what you learned in the course. So we did 10 homeworks. We did a lot of things. I'm just expecting that you can put together a robot to do something useful. And what that useful is up to you, how you would like to put the project. So don't spend too much time. I've actually give you some estimated time you need to spend. It's about 30 hours, about 2 to 3 homeworks, and we actually have a month left. So there is no homework, just you'll be working on this. Okay, so this is basically the other important thing, which is you are trying to create a scenario, ideally, like a manipulator sorting color boxes using vision, which is not taught, and I'll tell you about this in just a bit, and then using trajectory tracking. So once you have a manipulator, it has eyes, it has a camera, it can see things, it can basically pick and put it in, let's say, a box, so that trajectory generation and control has been done in one of those homeworks. The vision part has not been done, right? Then we take the second example. A legged robot uses rangefinder to assess a feasible path and uses trajectory generation or tracking to navigate along terrain. So this is basically, imagine a legged robot, and I've not done that. This is the next thing I'm going to talk about, or do a legged robot next after we finish tracking. There's no homework on that. So that's not been done, but I will show it to you how to do that. Rangefinder is something I need to show you. But then once you have that, there's another aspect of planning the path when there are obstacles, and then using trajectory generation tracking. This is something which you've done in this class in the first homework. So it's a mixture of 2 things. One thing we've done in the homework 1 through 10, and then there's some part which we have not done in the homework, first 3 homeworks, right? So that's something we need to figure out how you're going to learn that, and I'll get to that in just a bit. So what I expect you to do is to choose a robot which you have not done in the class. So UR5, I've explicitly talked about this one in the class. I've done lots of examples. You've done the Trosan robot in your homework exclusively, so don't use that. And then we're going to use A1 to do our control, but Go1 and Go2, which are 2 more robots in this menagerie, actually have the same mass distribution and leg length and so on. Here are some of the options. There are lots of options. As you can see here. Okay, and then if you think there's something else you want to do, that's absolutely fine. As long as you limit it to a wheeled robot, not a wheeled robot, a legged robot or a manipulator. You could also combine the 2. You could put a manipulator on top of a legged robot. That's absolutely fine. Okay, where would we? Did I close it? Okay, so that's the expectations. Now, the setup. Now, what I did was, there are 3 steps, and that's just to make it easier to understand. First step is you choose a manipulator legged robot. Okay, and as I said, you cannot choose a legged robot which you've done in the class, and I've given you all the various ones we did in the class. So pick that first, and you should use some of the techniques we develop in homework 1 to 10. Okay, and that will depend on the application you choose. Like for a trajectory generation tracking, you probably need, of course, to use the trajectory generation splines or whatever you want, and then tracking you need to use one of these controllers. So you need to use that. And then if you're working individually by yourself, you have to use something which we've not covered in the first 10 homeworks. Okay, so this is something which I will be talking about in the next few weeks, but you need to make the determination what you're going to do right away in the first week, because you're going to choose a project right in the first week. Then if you're working in groups of two, you have to do a little bit more. You have to try to find two things which you have not done, not just one thing. And this is just because to make it fair to people who are working in groups, to be able to sort of do a little bit more work compared to somebody who's trying to do this by himself. So if you're in a group, do all three steps. If you're doing it individually, just do 1 and 2. Okay, the first part you can do it, I believe, easily if you have done the homeworks, because that's just taking the homeworks and just implementing this. So now what sort of projects? First of all, this is not an exhaustive list. This is just something to give you an idea. You can look over, I would say, start with YouTube. There are lots of people doing lots of interesting things. Example would be, and this example I told you just some time back, you could use a color sensor to detect colors, and then you can have a robot doing sorting. You could have a tic-tac-toe playing robot. You don't have to have X's and O's. You could have different colors there. That's absolutely fine. You could use the image sensors. So the color sensors basically only distinguishes colors, red, blue, green. You could use an image sensor to detect objects. So it could be, let's say, a square from a circle and so on. And it could just sort, say, a mixture of items. Now, we've not done color sensor and we've not done image sensors. Now, I do have plans to actually show you how to use. It's the same sensor. It's basically using a camera. And once you have the camera pointing at an object in MuJoCo, you can actually get the pixels. And once you get the pixels, you can do anything with it. You could use, there's a OpenCV, which is basically the Python library for doing image processing. You could use that image processing. And this is where you're free to use ChatGPT. I'm not going to teach you how to use OpenCV, but if you have anything in mind, if you put instructions in ChatGPT, it actually tell you, and you should try to figure out what it's doing, not just copy paste the code. So I will show you how to use the color sensors in MuJoCo, but I expect you to do a little bit more digging and figuring out how to use the image sensor in one of these settings. Okay, rangefinder I'll show you how to use. There is an example. I did this in one of my projects, the wall following robot. So this is how the project was. This is basically a robot on wheels, but it's basically using 5 sensors. There's one rangefinder in the front, 2 on the left, 2 on the right, and it's basically navigating along the wall to reach the black dot, which is the goal. So here, you need to code in this case, it will be obviously a legged robot to go like this. You could actually also do this with a manipulator. It requires some kind of large workspace to do it, but I would more likely do it with a legged robot. But that's a neat demonstration of rangefinder. So rangefinder basically gives you the distance from an obstacle. Okay, and then there is touch sensors to detect contact. You could do a legged robot jumping. I will be doing trotting, which is different from jumping. I'll show you how to use the touch sensor. You could do, this is probably the simplest thing to do. Take any sensor. This is probably the easiest one, which is basically you take a sensor, you add noise into it, and use some filtering to remove the noise. It's the easiest way you can actually satisfy the second requirement if you are trying to do this with 2 people. You could also do it if you're doing it individually. It's the easiest one, I think. Then you could do trajectory tracking for a legged robot. So you can check this video. It's basically the legged robot is following an shape 8. So that would be sort of like inverse kinematics. You could use motion planning. So what is motion planning is when you have obstacles, how do you get a robot to go from point A to point B? I actually had some lecture notes here. You can see this, lecture 15. There are like 3 or 4 methods I use for planning. You could take one of them and implement them. And then this would be kind of challenging. If you want to do, take the quadruped code, which I'll be teaching next, and you could do it for some other robot, that's fine too. So in that case, you could just reproduce what I did. Okay, grading. So what I did was to keep you for you to make reasonable progress in the project and not having to rush this. I just ensured that you are setting up some uh, code or setting your project such that you are delivering some things every week, okay, every Sunday. So first, I put literature review, but really all you're doing is you're coming up with 3 ideas or 2 ideas, depending on you're doing it individually in group of 2, sending it to me as a slideshow. And really, I've told you how much time you should expect to spend more than 2 hours on researching topics. And then you shouldn't spend more than 10 minutes doing the slideshow. The slideshow is just for information. It's not like how beautiful you can make a slideshow. It's not important. It's important that you convey your information through slides, for me to grade you. So this 15% is the percentage with respect to your total course grade. Okay, so that's that. And then you give me 3, and then I can tell you if you're taking a too ambitious a project, and then sort of help you to tone it down, or I'll tell you it's inadequate, you need to add more. And then the next one, you do some basic programming for the robot. This will be something you did in the first 10 homeworks. Again, I give you the expectation, don't plan to spend more than 8 hours. You shouldn't have to do that. And then you send me the Py files, then you show some more progress towards the project. Then finally, on the final week of classes, Monday and Wednesday, you will stand here, you and your partner, or individually, and talk about the project. I'm thinking it'll be 10 minutes, so it's about 10 slides. I think 10 minutes is easy to do if you have worked on it hard enough. And really, the goal is not like you may fail. That's fine in the project. You may not be able to do what you started off. That's absolutely fine. Please try to convey all issues you faced and suggestions for improvement. So really, it's not a test of how glossy your project is. Of course, if you make it successful, it's good for you. But if you try hard enough, then I don't see why you cannot get full points. And then, if there are suggestions, you want to put those suggestions, send it to me by May 7th, and that's that. So I'm also trying to enforce attendance. So I only want you to come. Throughout the course, I did not enforce attendance, but I really want you to come on 28th and 30th, and that will be part of your grade for the project. Okay. So we'll get to the details as things come, and as the milestones come forth. It's just too many things going on right now, and I think it just become more clear as we work through the weeks. Okay, but this is going to be a last homework which I already assigned, and of course you're going to do this part, which is not too exhaustive. It's not too much. The first deadline is next Sunday, but it's really not too much work, about 2 hours of work. But you'll do this and you'll do the homework, and then it will become a little bit more involved in terms of project work. Okay, any questions?